All right, welcome to our video on geologic time. In our daily life, we measure time by minutes, hours, months, and years. But if our planet was a sentient being, your life would begin and end in the time it took Earth to blink. So, how would the Earth measure time? Using the best evidence, we geologists and physicists place the Earth at about 4.6 billion years old. Now, that's billion with a B, like Billy and ball. So, how would we measure the entire history of the Earth? Well, we would need a different timeline, wouldn't we? A geologic timeline. And spoiler alert, we have gone through thousands and thousands of pieces of evidence to finally create such a thing. But to really understand this timeline, we need to understand how it was made and ask some pretty fundamental questions that underpin any discussion of time. Specifically, like, well, what is time? So, as you look at this image, right, it's a series of photos, and probably immediately you know that the photos on the left were taken before the photos on the right, right? That's how camera film works. Our brains are really good at organizing a series of instances into a coherent story with a before, now, and a future. And some of this is cultural. Western culture has always viewed time as a linear arrow pointing into the future instead of a cycle that repeats itself in novel ways. And that's one of the assumptions that we make in most science, that time is like a steady stream of photographs pasted together into cause and effect, or maybe even a bunch of rocks stacked one on top of another to show us history. Okay, anyway, I'm going to pull back before I turn this into a philosophy class. So, what kind of scale are we talking about here? Most of us tend to view things from the perspective of our own existence. We divide time into old, which is basically everything before our time, current, things that we experience, and the future, which we won't see. When we say that something is ancient, we mean maybe a few thousand years ago, or like 4 or more generations ago. But geology deals in very long periods of time. When a geologist says ancient, they're referring to things that happened millions to billions of years ago. And these vast periods of time set geology apart from many other sciences. This appreciation for the truly vastness of the past is something that many geologists are pretty comfortable with. And as someone learning about geology, you need to be at least a little bit appreciative of how long geologic time spans. But how do we know this? Well, let's take a look at some sedimentary rock units in the western U.S. See that thick sandstone unit called the Dakota Sandstone? Well, that one rock unit took 65 million years to form. That's 65 with 6 zeros behind it years. Okay, if we put things into a human perspective and assume an average lifespan of 80 years, that would be about 800,000 generations of humans. But how do we know the ages of the rocks? Well, there's 2 ways. There's the stratigraphic way that we learned about in the last module using those principles of geology. So if we look at those, we know that this rock unit was first and oldest, then this one, and so on, till we get to this cross-cutting dike here. And the youngest units are the Wasatch, right? So then, what about these numbers? How do we know those? Well, that's its own kettle of fish. So I'll answer that question in the next video. But if we take a look at all the rock units from all over the world, and if we were to stack them up in order of relative age, like in the previous examples, we can start to see a timeline. The oldest rocks are at the bottom and the youngest are at the top, right? Now, you may be asking yourselves, well, how did we name these units? Well, actually, they were named often by where they were found first. Right? Like the Cambrian rocks first described in Cambridge, England, or the Jurassic for the rocks that were described in Jura, Germany. And I bet you can figure out where the rocks of these ages were first described, right? All right, but if we stack up all those rock units from all over the world in order of relative age, then we get this time scale. So that brings us here, a timeline called the geologic time scale. All of those periods are in order, constrained with ages through absolute dating. And speaking of absolute dating, let's go ahead and move on to that video.